Hey boys and girls, it's Miss Guild here. Today we're going to talk about understanding three-digit numbers. So before we talk about what are three-digit numbers, we need to talk about what does it mean to be 100. So if you have a hundredths chart in your room, I'm sure you've seen something like this. Take a second to pause the video and look over this hundredths chart at the different numbers. The hundredths chart is made up of 10 tens, so you can skip count by tens to get to 100. You can go 10, 20, 30, and you can see they're listed right here, 40, 50, 60, 70, 80, 90, 100. So that's 10 tens in 100. 100 also equals 100 ones. So you can count by ones all the way till you get to 100. And 100 is the number that comes right after 99. So the number 100 can be shown as hundreds, tens, or ones, just like I was showing you. This is an example of a 100 flat. You will be using these when you do base 10 blocks in the next few weeks. Here we have 100 ones. These are also called bits, or your teacher may call them just ones. So there are 100 ones in the number 100. And these are called 10 rods. And there's 10 tens in the number 100. To be a three-digit number, you have to have a hundredths place. The hundredths place is the third place from the right, a tens place, which is in the middle, and a ones place. The hundredths place tells you how many hundreds are in the number. So we can count three-digit numbers by hundreds, tens, and ones. Let's look at these examples together. If you have 200 flats, let's count to see how much that would be. 100 plus another 100 would be 200. So we're going to write the number 200 here. And we're going to write it as our number word, 2, and I don't have space, I'm going to write it underneath, 100. Here we have 100, 200, and then we want to continue counting from there. 210, 220, 230, 240. So we would have 2 hundredths, and how many tens was that? 4, yes, because I counted 240. And we know that 4 tens is equal to the value of 40. So 2 hundredths plus 4 tens, we counted 240. Let's try one more together. We still have 200 flats, 100, 200, and let's continue counting. 210, 220, 230, 240. Now we have to skip and add ones to that. 241, 242, 243, 244, 245. So as we're counting, we counted 2 hundredths, 1, 2. 1, 2, 3, 4 tens, because it was 40. And we know from this one that 4 tens is equal to the value of 40. And we counted 1, 2, 3, 4, 5 ones. So as we were writing the standard form for this, 2 hundredths plus 4 tens plus 5 ones, we counted all together 245. So you would write it 245. 2 in the hundreds place, 4 in the tens place, and 5 in the ones place. Now I want you to pause this video and tell me how many hundreds, tens, and ones are in each one of these 3-digit numbers. Take a second to do that. Good, so the number 156, how many hundredths does that have? Hopefully you said it has 100, because the 1 is in the hundreds place. It has 5 tens, the 5 is in the tens place, and 6 ones, the 6 is in the ones place. Now let's fill these out. 296 would be 2 hundredths, 9 tens, and 6 ones. 385 would be 3 hundredths, 8 tens, and 5 ones. And 905, this guy was trying to trick you on this one. How many hundredths does this one have? 9. What about tens? If you said 0, I wasn't able to trick you. Because there is a 0 in the tens place, you need to make sure that you write 0 here for the tens. And there are 5 ones. That placeholder 0 is very important anytime you see a 3-digit number, wherever it may be, because it tells you that there are no numbers in that place. Now let's look at a hundredths, tens, and ones chart to fill in this number. We're going to write the number 307 in the chart below. So the number 307 has 3 hundredths. Trying to trick you again, you can see. It has 0 tens, because there's a 0 in the tens place, and 7 ones. Now, just by writing hundredths, tens, and ones, you can represent a 3-digit number. But there are other ways you can write it other than hundredths, tens, and ones. So let's look at the number 356 to write it 3 different ways. In the number 356, we could see, and this is the number 356, we could see that it has 3 hundredths. So I have 300 flats, 5 10 rods to show there are 5 tens, and 6 1 bits to show there are 6 ones. If I were to start filling in my chart here, I could see, well, I can't write over. If there's already a 0 there, I can't write over that. So we couldn't use this one to show 3 hundredths, 5 tens, and 6 ones. I can't use that one either because there's a 0 already there. But if I look at this last row here, the hundredths space is blank. So I can fill that in with my 3 hundredths. The 5 is already there, 5 tens, and 6 ones. Now that's one way we could show 356. But let's look at 2 other ways to do that. If you go back here to the first one, this chart says we cannot use any 100 flats to show 356. And we can't use any tens. We can only use ones. Well, we know that ones, we would have to have a lot of ones. Think about it like money. If you had 356 in dollar bills, you would have to have 356 56 $1 bills. So that's what it would be in ones. It would be 356 ones. Now, if you were to show it here in the second one, you still can't use hundredths. Oh, that means we can only use tens and ones to show 356. Well, we already have the 6 here for us. And we're going to look and see if we can see a pattern here. The 6 is already in the ones place. So we're left with the numbers that are in the hundreds place and the tens place. We go back to our hundreds flats and our rods. We can see that if you have 100 flat, how many tens is that? Good, it's 10 tens. We talked about that earlier. So 100 is equal to 10 tens. So if I were to separate this, this would be 10 tens. This would be 10 tens. That means another 100 flat would also equal 10 tens. So this would be 10 tens. This 100 flat, 100 would also equal 10 tens. And this last one would equal what? Good, 10 tens. So if we put those together, since we can only use tens and ones, how many does that equal? 10, 20, 30. 10 plus 10 plus 10 is equal to 30. That means in the number 300, that's 30 tens. So 300 is equal to 30 tens. Whoa. So if I had $300 in just tens, I would have 30 tens. Now, if I wanted to still make the number 356, well, 300 is equal to 3 tens. But what about the 5 that's already in the tens place? We have to add that to our 30 tens. So we have 30 tens that equal 300 plus 5 more tens. So 30 tens plus 5 more tens. What does that equal? 35 tens. And you have your 6 ones. So let's go back to our chart. If you can't use hundredths, we just said that you could have 35 tens and 6 ones. I do see a pattern because I see the number 35 is right there in the hundreds and the tens place. 356. So this is 3 ways that you can make the number 356, but there are plenty more ways that I'm sure you will practice with your teacher on creating different numbers. Now, let's start practicing. We're going to do one together, and then you will have a chance to practice one, either by yourself or with a friend. If John puts his coins in stacks of 10, he has 13 stacks with 5 coins left over. How many coins does John have? Now, if you remember back when we talked about word problems, we said that every time you have a word problem, we use our cubes method. So we're going to go back to our cubes method, and we're going to break apart this word problem and solve it together. The first step on our cubes method was to circle the numbers that are important. So let's go back and we read the first sentence, and I see that John puts his coins in stacks of 10. That number 10 is important. He has 13 stacks with 5 coins left. So all of these numbers are very important for us to solve this problem. The second step is to underline the question. How many coins does John have? Remember, our question is always the last sentence in our word problem, and it's followed by a question mark at the end, as well as question words that start the sentence. The next step is to box in our clue words that will help us to decide if we are adding or subtracting to solve this problem, or if it's a problem like this, we may have to draw a picture to help us to solve it. John puts his coins in stacks of 10. I think that the words here that are important would be stacks, because that tells me that if I'm using stacks of 10, I think about those 10 rods that we were just looking at. He has 13 stacks with 5 coins left over. I'm trying to visualize this, and I think if he's putting coins in stacks, he's stacking up his coins. But then you have 5 coins that you can't stack up because they don't fit into groups of 10. And we want to know how many coins does John have altogether. So now let's eliminate the extra information and evaluate more what we need to do to solve this problem. So we're going to take our tools here and we're going to cross out all of this other information that we don't really need to solve the problem. And let's start drawing a picture of what we see. If John's putting his coins in stacks of 10, he has 13 stacks of 10. Instead of drawing a 10 rod, I'm going to draw like a tally mark to show a 10. So this would represent 110. And he puts them in 13 stacks. So I'm going to draw 13 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's a lot of 10s. With 5 coins left. Well, if there's 5 coins left, those 5 aren't in stacks. So I'm going to represent those by little ones, or you could say these are bits. 2, 3, 4, 5. You can see the last one there. Now we need to know how many coins does he have altogether. Well, we know these are 10, so we can skip out by 10s to find out how much. 10, 20, 30, 40, 50, 60, and I hope that you're following along and doing this with me. 70, 80, 90, 100. Oh, that's a 100 flat. I'm going to go ahead and box that as my 100 flat. I just counted 10 10s to make 100. Let's continue. 110, 120, 130. Now we have to skip over and think, now I'm not doing 10s, I'm counting ones. So 130, 131, 132, 133, 134, 135. So he has 135 coins. Wow, that's a lot of coins. Let's do another one like this. This time, you can practice with a friend or by yourself. Make sure you're drawing a picture of your 10 rods and your 1 bits if you need them, and you're following the steps to solving our problem with the cubes method. Take a second to pause the video and solve this problem. Okay guys, so hopefully you've had enough time to solve our problem either with a friend or by yourself. So let's take a moment now to make sure that you have the answer correct. If Blake puts his coins in stacks of 10, he has 18 stacks with 6 coins left over. How many coins does Blake have altogether? This is very similar to the one that Ms. Gall just did with you. Let's go through our cubes method and make sure that we are following each step. The first step is to circle our important numbers. So going through our first sentence, we see that the important number is 10. He's putting his coins in stacks of 10. I'm going to make that darker so we can see it. He has 18 stacks. That number 18 is important. With 6 coins left. How many coins does Blake have altogether? So our next step, of course, is to underline the question. So our last sentence, how many coins does Blake have altogether, is our question. That is what we're solving for. Now we need to box in our clue words. So just like the last time, one of our clue words was our stacks of 10. The stacks of 10 tells you that you will be drawing 10 rods to solve this problem because they are in groups of 10. He has 18 stacks with 6 coins left over. Remember, those 6 that are left will be the 1 bits because those don't fit into a group of 10. And we want to know how many coins does he have altogether. So we know that altogether, we're trying to see how many in all. Now let's eliminate our extra information by crossing it out and only looking at our clue words. Now we're ready to solve it. Let's draw a picture just like the last time, and we're going to use the same idea of the 10 rods and the 1 bits to solve it. So we know that he has stacks of 10, so we're going to draw the little tally to show 110. And we need 18 stacks. So we're going to draw 18 tens. Hopefully you did this. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 stacks of 10 with 6 coins left. Remember, those 6 that are left are going to be 1s. 1, 2, 3, 4, 5, 6. And always go back and check your work to make sure you drew it correctly. So as we go back over and count it, we want to make sure we have 18 stacks with 6 that are left. So let's skip count through our 18 and see how much that is. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And what did I do last time? Make sure you are making 100 flat out of those 10 tens to show you 10 tens equals 100. So that's 100, 110, 120, 130, 140, 150, 160, 170, 180. So we have 180 tens. Now we need to skip and add 1s to that. 181, 182, 183, 184, 185, 186. He has 186 coins. Okay, that's all I have for you today. Make sure that if you are solving word problems just like this that have to do with understanding 3-digit numbers, that you are drawing those 100 flats or our rods and our 1 bits. Thanks, guys. See you soon.